Hi there. This is going to be a video that takes you through the examples on the 7.3 worksheet, which is graphing log functions. Like a lot of things, when you graph it, you can make an XY table that will help you get the first few points plotted for the graph, and then you can just draw your curve through the points from there. The way you figure out which x values to use, convenient x values for your table, are to, first of all, generate a list of powers of whatever your base is. In this case, this is a power of 2, that whatever the subscript is. I would just take whatever that subscript is and generate a list of powers of that number. I'd encourage you to do like the negative second power, the negative first, the 0 power, the first power, and the second power, regardless of what that base is. If you generate these 5 numbers, it's going to help you come up with x values that'll work very nicely in your xy table. So the way you get a negative power is you just you ignore the negative and then make the answer a reciprocal. So I would look at this as 2 to the second, which is 4, and then since it was a negative exponent, I would then call it 1 over 4, because a negative exponent gives you a reciprocal result. Same thing with 2 to the negative first. That would be like 2 to the first, which is 2, and then take the reciprocal. That's what the negative exponent does. Anything to the 0 power will give you 1 every time. 2 to the first is 2. 2 to the second is 4. Now these are not going to be necessarily the x values you use. These are going to be what you want this quantity to equal. Because whatever this quantity is needs to be a power of 2. So my quantity is x plus 1. I want x plus 1. I want the quantity to come out to a fourth. I want x plus 1 to come out as a half. I want x plus 1 to come out as 1. I want x plus 1 to come out as 2. And I want x plus 1 to come out as 4. So step 1, find powers of your base. I would use these 5 exponents. Step 2, whatever your quantity is, set that equal to the powers of your base that you got in step 1. Then you simply solve each of these little mini equations for x. So I have to take away 1 from both sides. 1/4 minus 1 would be negative 3/4. A half minus 1 would be negative 1/2. And then obviously 1 minus 1 would be 0. 2 minus 1 would be 1. 4 minus 1 would be 3. These are going to be the x values that you use in your xy table. I'm now going to make that xy table, and I'm going to use these 5 x values. And to get my y values, I'm going to plug each one back into the original equation. Negative 3/4 goes in for x. Adding 1 gives me 1/4. So now I'm doing 3 times log base 2 of 1/4. Log base 2 of a fourth means 2 to what power? I won't use x again. 2 to what power gives me 1 over 4? Well, if 2 squared gives me 4, 2 to the negative second gives me 1/4. So I really have, this is really negative 2. So my y value is 3 times negative 2. That's going to be negative 6. If I plug negative half in for x, I get positive 1/2 in my parentheses. To figure out what log base 2 of 1/2 is, first you can kind of go back here. we have -1 as a result, because it's saying 2 to what power gives you a half. Well, 2 to the negative first is what gives you a half. So we really have 3 times -1, which would be -3 here. Plugging 0 in for x gives us 3 log base 2 of 0 plus 1, which is just 1. And look, log base anything of 1 is always going to give you 0, because base to the 0 power is what gives you the 1 result. So this is really 3 times 0, which is 0. Plugging in 1 for x, we'd have 3 log base 2 of 2. Log base 2 of 2 is 1, because 2 to the first power is what gives you the 2. So we really have 3 times 1, which would be 3. And plugging in 3 for x would give us 3 log base 2 of 4. Just looking at log base 2 of 4, the result would be 2, because 2 to the second equals 4. So this is really 3 times 2, which would be 6. Once you've got your table filled out, you can sketch a graph. I need to get down to -6 and up to +6. I don't need to go too far in the x direction. So -3/4, -6 would put us somewhere around here. -1/2, -3 around here. 0, 0, 1, 3, and 3, 6. And if you kind of look at this, the table, the x values are clumping up here. Like there's a big gap from here, a not so big gap here, a tiny gap here, a tiny gap here. If you keep working backwards, you'll find you never quite are going to get to -1. What I'm going to do is I'm going to draw in what they call a vertical asymptote at -1, because my x values are not ever going to reach that. It's sort of a half the distance to the goal line in football situation. If you keep committing penalties when you're already at your own 1-yard line, they're just going to move you to the half-yard line and the quarter-yard line and the eighth-yard line. You're never actually going to get to the goal line. -1 is sort of like the goal line in this situation. I apologize for the sports analogy if people aren't into that, but sometimes that works. Your final graph, once you draw the curve through it, looks something like this. Now, the way that you can tell there's a vertical asymptote without even plotting the points is to go back to the original log quantity. You get x plus 1 is our log quantity. Well, you can't ever have a log quantity of 0. So we'd have to say x plus 1, this log quantity cannot equal 0. And if you solve this for x, you get x cannot equal -1. And right away, that's going to tell you where that vertical asymptote is. So if as a first step you want to go in and just set the log quantity not equal to 0 and solve it for x, that you can dot your vertical asymptote in right off the bat that way. We'll do that as our first step in the next example here. So in the second example, we have f of x instead of y, but don't worry about that. F of x behaves just like the variable y will. The one thing to notice, though, is that the log quantity is just x. This -2 is not included in parentheses, which means only x is what we're taking the log of. This -2 is like a whole separate term. So what I'm going to do is I'm going to figure out where the vertical asymptote is going to be for this graph by just taking whatever the log quantity is, in this case it's simply x, and saying x can't be 0. So whenever I draw my graph, the first thing I'm going to do is I'm going to dot in a vertical line down x equals 0. The graph will approach it, it will get very close to that line, but it is not ever going to touch it. Alright, so first I need powers of 3. That's my base. So I'm going to do 3 to the -2nd, 3 to the -1st, and so on. I know 3 to the second is 9, which means 3 to the negative second will be 1 over 9. I know 3 to the first is 3, which means 3 to the negative first will be 1 over 3. 3 to the 0, like anything to the 0, is 1. So these are just some real common powers of 3. What I need is for my log quantity, in this case x, to equal these powers, which is going to be really easy since x is all by itself. That means x has to be any of these 5 values for my table. So then I'm going to make my table. If I plug 1/9 in for x, I've got to figure out negative log base 3 of a 9th and then take 2 away. I'm just going to focus on this much for now. This box here is asking me 3 to what power gives me 1/9? And the answer is negative 2. 3 to the negative second power is what gives me 1/9. So this thing in this box can be simply replaced with negative 2. So now I've got negative 2. That's what this box is negative 2. This thing was already there. And then minus 2. This is positive 2 minus 2 would give me 0. If I put a third in, I get negative log base 3 of a third. Log base 3 of a third, just looking at this much, is negative 1, because 3 to the negative first power gives me 1/3. So I've got negative, and then negative 1 for the box, and then minus 2. This is 1 minus 2, that's negative 1 as a result. When you put 1 in for a log quantity, log base anything of 1 is going to be 0, because base to the 0 power equals 1 every time. So we really have negative and then 0, so 0. Minus 2 would be negative 2. And you can kind of see where the table's moving. If you pick your x value strategically, this should happen. Some sort of pattern should develop in the y column. Plugging 3 in for x. When the base matches the quantity, the result will be 1, because base to the first equals itself. So we have negative 1 minus 2. And finally, plugging in 9 for our quantity, 3 to the second is what gives you 9. So this much is just positive 2. We're going to end up with negative 2 minus 2. From here we can make a graph. Just looking at these coordinates, I need to get out to 9 units in the x direction. I need to get down to 4 in the y direction, and I don't really need to go far from anything else. The vertical asymptote was at x is 0, so I'm going to dot that in on my graph. I'm going to plot these points. 1/9 comma 0 is just off the origin. 1/3 negative 1 is nearby. The rest are pretty easy to find. So you have a graph that starts out very steep and ends up flattening out, never quite getting to an x value of negative 1. It'll eventually drop down to all the y values in the world. It'll just take a while to get there.